Section 5.2 is systems of linear equations in 3 variables. In section 5.1, we did linear equations with how many variables? 2. We had 2 equations and 2 variables, and we had a variety of methods to solve them with. Substitution, addition, also known as elimination, and graphing. So in this section, we're going to see what happens or how things sort of are a little bit different when we have 3 variables instead of just 2. So to start with, we had encountered this description of a solution last time. What is a solution in 2 variables? What does it mean to have a solution to the system? Okay, what is equal to each other on both sides? Can you be a little bit more specific, Addison?
The same number on both sides.
Okay, and how did we get to that point? There you go. So if we plug in the points that we're given, which in 2 says 2, we had an x and a y, right? Then we actually got the same value or number value on each side. And the same thing's true for 3. If I plug in the x, the y, and the z into all 3 equations, and I get the same number on both sides, that is, it works, it's true, then I have a solution to the system that's for a system of 3 equations. So this is a -2, 5, and 3. And we're going to check and see if it's a solution to this system of equations by plugging it into all 3 of them. So on the first one, if I plug in -2 plus 5, and then minus the 3, the question is, does it in fact equal the 0 that's on the other side? And I'm seeing some nodding of heads. Yeah, it does. This is the same on both sides. So it works for one equation. Let's try the second one. 3 times the 2 minus the 5, and then plus 3 times the 3. And the question is, does that equal -2? Does it work? Yep, it does. And then on the third one, I have 2. Hang on, that should have been negative there. I left my negative off. You guys have got yours in there. -2 plus 2 times the 5 minus 3 times 3. And does that equal -1? Does it work? Okay, so it's important to realize that it could work for 2 and not for all 3, right? Like that's actually a legit possibility. Or it could work for 1 and not for all 3. So you actually have to test all 3, okay? So you test all 3 equations. If it works in all 3 equations, then we need to make sure, either way actually, that we answer the question asked. The question said, is it a solution? And the answer is yes. Okay, everything I did before is the showing the work to justify the answer. The answer should say yes. Okay, so kind of like we did in the last section as well, that's great if somebody just says, here's a solution, does it work? But where did that come from? I mean, how do we know to check that particular solution if it's not given to us? So, or at least that potential solution. Well, we can find it by solving them ourselves. So this is a abbreviated description of how we solve a system of 3 equations. We use addition or substitution to eliminate the same variable from 2 pairs of the original equations. We solve the remaining system of equations with 2 equations and 2 variables. We use an original equation to find the 3rd variable. And then whether we have to show it or we simply want to double check and make sure we're right, you can always check to make sure you're right on the solution. And I'll tell you, it's a good idea. When I was preparing this lesson, I was in the car. Well, I wasn't driving. My husband was driving, but I was riding in the car, and I knew that my answer was wrong because it didn't check out in all 3 equations. And it took me 20 minutes to find my mistake. It was the dumbest thing. It was a mistake of a negative. Negatives are really common mistakes, right? They're easy to make. And I made a mistake with a negative, and it threw everything off. So checking your work to make sure you got the right solutions is a really good idea. Okay, you guys ready to try some? Okay. So we're going to actually do probably of the three equations here, this is the most challenging of the three. The first thing that we need to do, in fact, just to help us out, is to label our equations, because that way we can talk about them and reference them, and we are all on the same page. So I'm just going to label them 1, 2, and 3. Now, while it says over here on step 1 we can use addition or substitution, and that's true, you can, we're going to use the addition method because it's the simplest to use when you get lots of variables going on, okay? When you start using substitution, it makes things really messy with systems of 3 equations. So we're going to use addition. And we get to decide at the very beginning, before we do anything else, which variable does it look like it would be the easiest to eliminate? X, Y, or Z? So we got to pick one. So which one do you want to do? You want to do Y? Is everybody good with trying to eliminate Y? Yeah? Okay. So it's kind of nice for a couple reasons. Number one, Y is nice because there is a Y where it's singly by itself. But if you notice, there's an X that has that feature and there's a Z that has that feature, right? All of them have that possibility in this one. That's not always the case. Y is also kind of nice because it's negative. And so it's not all the same sign. Like my earlier class today decided to eliminate X, which is fine. But all the X's are the same sign, which means that we had a little bit more work to do when we were working with our negatives. Okay, so let's take equation number 2, and it will be the one that will be manipulated each time, right? So let's consider equation 1 and equation 2. If I were trying to eliminate the Y, it means that the Y's need to have the same coefficient and opposite signs. We're not going to mess with the first one. There's no need. I can leave it exactly as it is. 4x minus 2y plus z equals 13. What would I need to multiply the second equation by in order to get the y's to cancel out? A negative 2. So I'm going to multiply every component by negative 2. So this would be negative 6x. And then what? Plus 2y. That's kind of our goal, right? Then what? Equals negative 26. Nice. Okay, so, right, the y's cancel. We only have 2 variables left now. How many x's do we have? Negative 2x. How many y's, or z's do we have, excuse me? Negative 3z. And what are the constant value on the right-hand side? Negative 13. And we're going to call this equation 4 because we're going to need to use it again in a minute anyway. So now we'll have a label for it. All right, so I took equations 1 and 2. Now I have to either take equations 2 and 3 or equations 1 and 3. Okay, I got to take 2 of the other equations, 2 equations that I didn't take already, and do the same thing, eliminate a y. So which equations would you like to take? 1 and 2 are done, so I either can do 1 and 3 or 2 and 3. I think 2 and 3 is going to be easier because equation 2 still has that negative y in the middle. Okay, so equation 2, equation 3. Again, I'm going to leave equation 3 as is because it's easier to manipulate equation 2 to cancel out my y. So what would I need to multiply equation 2 by in order to get the y to cancel out? A 3, and it's a positive this time, right? A positive 3. So let's go through that. What do I have for each of the variables and their coefficients? How many x's do I have? I already had a 3x, and I'm multiplying by 3, so a 9x on that one, yeah? What about my y's? That's negative 3y. Z's? Plus 6z equals what? 39, yes, good. All right, so the y's cancel, which was our goal. How many x's do we have? 10x. And then what? Plus 3z equals 29. And this we will call equation 5. Okay, so here's the cool deal. What we've done so far has now given us two equations, equation 4 and equation 5. There are two equations and two variables. And we've already dealt with how to do that. We did that in section 5.1, right? So looking at those two equations and those two variables, we need to eliminate a variable. Which one's going to be the easiest to eliminate? The 3z is, isn't it? It's very nice. So I'm just going to rewrite equation 5 underneath equation 4, so there's a little bit more space over here. I have 10x, I have plus 3z equals 29, and we're going to add them up. How many x's do I have? Z's cancel. 8x, and what does it equal on the other side? 16. So what does x equal? X is 2. Okay, now I've got 5 equations on the board, 1 through 5. I have a value for x, and I want to find one of my other values. Where do I have to plug it in? I only have like 2 choices.
Equation 5.
Yeah, I got to plug it into equation 5 or 4. If I try to plug it into 1, 2, or 3, I can't solve for either of the missing variables, right? I'll still have 2 unknowns. But equation 5 and equation 4, if I plug it into either of those, I can solve for z. So which one would you like to plug it into, 5 or 4? 5. Somebody said 5, so we'll go with 5. All right, so if I plug it in over here into 5, I have 10 times 2 plus 3z equals 29. If you chose equation 4, you'll get the same answer, so no worries on that. Let's see, that gives me 20 plus 3z equals 29. If I subtract the 20, what will I have? 3z equal 9. So what's z? 3. Okay, I got my variable value for z. So now I know x and I know z. What's left to find? Y. And any of the equations 1, 2, or 3 will do that for me, right? So let's pick one. Which equation would you like to use? 2? All right. Equation number 2 has 3 times x, so that's 3 times 2, minus y, plus 2 times z, which is 3, equals 13. A little bit. So I've got 6 and 6. Right, so these two add together to be 12. So I have negative y plus 12 equals 13. So negative y equals 1. So what's y? Negative 1. Now, at the end of our section 5.1, like at the end of one of those problems, we would always write our solution as an ordered pair, right? X comma y inside of parentheses. We're going to do the same sort of thing here, but we're going to write it as an ordered triple, x, y, z. So the x value was 2, the y value is negative 1, and the z value is 3. And I'm not going to take the time to do it, but could we check to make sure that this is really the solution and we didn't make a mistake anywhere? Of course, we could. Now, we've kind of already checked it, if you will, into equation 2. I mean, that's how we got the last variable. So it would really just be a matter of checking in equations 1 and 3 to making sure it works. Any questions before we go to the next one? Okay, let's try another one. We're going to label them 1, 2, 3. And what I need you to do next is to decide which variable you want to eliminate. Z? Z is really nice. Why is Z really nice? Because you got positives and negatives and they're all 1, right? That's friendly. It is. So tell me which 2 you'd like to take. 1 and 2. Okay, so equation number 1, which is x plus y plus c equals 6, and equation number 2, which is 2x minus 2y minus c equals negative 5. Don't have to multiply anything. We just get to add them together. The z's cancel. What am I going to have remaining?
3x minus y equals
3x minus y equal 1, and I'll call this equation 4. Okay, I need to take two equations now. They can't be 1 and 2. I already did that, so what would you like to take? 1 and 3. So 1 is x plus y plus z equals 6, and 3 is 3x plus y minus z equals 2. Okay, z's cancel. They add to 0. What am I left with?
4x plus 2y equals 8.
Now, we could use this equation as is, but do you notice they're all even? Yeah? So I'm kind of inclined to say, well, let's just divide them all by 2 to make the number smaller. And we can do that. As long as we do something to every piece of it, we're allowed to do that. We can divide every term by 2. So this can become 2x plus y equals 8. And why might that be a friendlier form of the equation when I compare it to number 4?
Equals 4.
Oh, I'm sorry. You're right. Equals 4. What were you saying, Amos? Yeah, the y's will automatically cancel now when I add these together, right? One's positive y, one's negative y, coefficients match. Okay, so if I write in equation number 5 here, I have 2x plus y equal 4. Y's cancel like we said. What else do we have?
5x equals 5.
5x equals 5, so what's x? 1. All right, where would you like to plug the 1 in? Which equation? I've got 5 equations on my screen. Number 5? Okay. If I plug it into number 5, this would be 2 times 1 plus y equals 4. What would y equal? 2. Actually, I'm not going to square that in just yet. That's not my final answer. So the last thing to find is z. Where would you like to plug the x and the y in? 1. 1's nice. X is 1 plus y is 2 plus z equals 6. What's z? 3. Okay, if you stop right here, you stopped too soon. What do I still need to do? Put it in an ordered, and it's an ordered triple because there's 3 of them terms, right? So I've got the ordered triple 1, 2, 3. Okay. Let's try one more together. First thing to do is to decide what you want to eliminate. Wise? Good with everybody? Okay. Now, sometimes there's not necessarily a natural choice, right? You guys understand that. So if Amos decides to eliminate y's and Zoe looked at this and she didn't see the y's initially and so she decided to eliminate z's, would it be okay? Yeah. You can still both get the right answer. There's nothing wrong with trying to do it different way, okay? So, all right, so let me label my numbered 1, 2, 3. I think we decided we want to eliminate y's. Which 2 equations would you like to take first? 1 and 2? Okay, so equation number 1 is x plus y plus z equals 9. And equation number 2 is x minus y plus 2z equals 1. Okay, so the y's cancel, and then what? Okay, 2x plus 3z equals 10. And we'll call this equation 5. I'm 4, sorry, not 5. 4. Okay, I need to take 2 more equations. Which 2 would you like to take? 2 and 3? So 2 is x minus y plus 2z equals 1. And 3 is x plus y minus z equals 5. Y's, of course, cancel. What else do you have? Two x plus z equals 6. All right, so this is equation 5. I can't just add these together as is. They're not exactly going to cancel something out if I try that, right? What do I need to do, or which variable would you like to cancel out at this point, x or z?
Oh, wait.
X? X would be nice, yeah. So if I cancel out X's, how am I going to do that? I need to multiply one of them by -1. I've already got number 4 written down up there, and so I'll multiply number 5 by -1 and just rewrite it underneath number 4. So if I do that, I'm going to have -2x, -z equals -6. So just as you guys planned, the x is canceled. How many z's do I have? 2z equals what? 4. So what's z? 2. Nice. What variable would you like to go back and find next? X. It's got to be x. Okay, so do you want to use equation 4 or equation 5 to do that? You do 5? Okay. So I've got 2x plus 2 equals 6. So that's 2x equals 4. If I subtract, what is x going to be? Another 2. And then I need to find z. Which equation would you like to use for that? 1? Okay. Yeah, that's what I meant, y. But yes, with equation 1. Thank you so much. So x is 2 plus y plus z is 2. And it's supposed to equal 9. What's y? 5. So what is my solution to this system of equations? 2, 5, 2. Careful to get them in order. They do go alphabetical, x, y, and then z. 2, 5, 2.